Angle 6. What do we think? Angle 6 for our warm-up. Owen got 45. Anyone else get 45? Nolan got 45. Awesome. Yes, 45 is correct. These two are consecutive interior. So this one would be 180 minus 135, which gives us 45. All right, how about angle 5? What do we get? Type in the chat. What do we think? 135. Anyone else get 135? Yes, we got a couple people agreeing there. Nice. Yes, angle 5 is 135. There's a couple ways you could get there. You could go, okay, 3 and 5 are alternate interiors, so they would be the same. Or you could go that these two must add to 180 since they're a linear pair, 5 and 6. Either way. How about angle 4? What do we think? Angle 4. Angle 4 and angle 8 will be the same. What do we think for those? All right, we got 45. Anyone else think 45? Agreement, disagreement? I agree. 45 looks good to me. Because 4 is, you can either think that it's alternate interior with angle 6, or you can think that it's a linear pair with angle 3, or even that it's consecutive interior with angle 5. Either way, whatever you kind of went with there angle relationship-wise, 4 would be 45, and then 4 and 8 are corresponding, so they would both be 45. Okay. Also, just kind of going back to Thursday for a moment, last week. And looking in Google Classroom real quick at some different options if you're having a hard time with 3.2 or anything from this chapter so far, actually. So some resources were posted here. We've got, of course, the video from class. And then we've got another video that I made a couple of years ago that used a little bit better graphics than just me drawing with pencil on paper. So if you would like to take a look at that, that's another option. It's also a much shorter video. It's only 9 minutes. And then we have 2 other example videos using parallel lines cut by a transversal that are just a couple minutes each. We also have a Kahoot that you can try if you would like to get some extra practice with the vocabulary. It's the same one that we used on Thursday. And then we also have a Quizlet that has some extra angle vocabulary practice. So anytime you spend either watching videos or working on either of these activities would be good to help you remember the vocab and, you know, kind of cement this in our brains. Anything you do now is going to help you on the test. We also had an exit ticket, so if you did not complete the exit ticket, make sure you do that. And then we had a big ideas assignment that looked like this. So before we get going on today's stuff, are there any questions from the big ideas assignment that we want to talk about? I believe we went over the first 3 of them or so together. But are there any that we would like to see done? All right, Christy, which one are you looking at? And there were 14 of them. She wants number 12. Okay. Number 12, the thing that throws a lot of people off is that it's a different looking picture than usual. But if you can imagine with me for a moment that the trees are the parallel lines and that the rope is the transversal, that kind of makes our lives easier here. So we're imagining that the trees are the parallel lines and the rope is the transversal. So then all we have to do is think about, okay, well, angle 2 and 76 degrees over here. The angle relationship for those is consecutive interior because they're inside the trees and they're on the same side of that transversal rope. So since they're consecutive interior, they think their food is safe, but it's really not. Yeah, I mean, they're doing their best here with that bear bag. Anyway, so we would go 180 minus 76, and that's how we would get our answer for that one, because consecutive interior means we add to 180. But yeah, usually a bear canister works a little bit better than the bag between the trees. So 104 is what we should get there. Okay. Any others that we want to look at? 13. Okay, so 13 is all about finding the angles and then stating the relationship. So let's do the finding the angles part first. Measure of angle 1. Well, we know this one is 150. What do we think angle 1's going to be? Anyone can answer here. Anyone have an idea of what angle 1 might be? Yeah, Marissa, you got it. 150 as well, because angle 1 and that 150-degree angle there are corresponding angles because they're both in that same spot within their group of angles. So actually, since we already kind of talked about it, all you would have to do for this part is grab the angle relationship. So corresponding angles, and we would stick that there. Okay. Then angle 2. Well, angle 2 and 150. Or we can also go angle 1 and angle 2 even. Angle 1 and angle 2 are vertical angles, so they're going to be the same. But you can also go, okay, angle 2 and 150 degrees, what kind of angle relationship do they have? Well, they're on opposite sides of this transversal here. 2's over here and 150's over here on the other side. And they're also exterior angles, so alternate exteriors here for angle 2 and 150. So I would grab alternate exterior and stick that there. And they are mowing the lawn right outside the portable. Seems to be kind of a Monday morning theme. So that's fun. Let's see. All right. So that's practice 3.2. If you have further questions about practice 3.2, feel free to ask them right after we get going on the assignment for today. But we're going to move on for right now. Also, if you have not submitted this yet, but you've done the problems, make sure you click submit so you can get your points. And also make sure you're using the check answer feature. Okay. So back to what we're doing for today. Today is 3.5. We're going to be talking about parallel and perpendicular slopes. Slopes of lines that are parallel and perpendicular. So we want to be able to use slopes to determine if lines are parallel, perpendicular, or neither one of those. And then we also want to be able to find the slope of a line that's parallel or perpendicular to another line. So here we go. Grab your notes and let's get started here. Okay, so this is 3.5 slopes of parallel and perpendicular lines. And we're going to spend 2 days on parallel and perpendicular. Today we're going to be finding slopes and things like that. tomorrow we're going to actually be writing the equations of lines that are parallel and perpendicular to each other. So that's kind of where we're headed. So the first thing that we need to know when we're talking about slopes of parallel and perpendicular lines is how to find a slope. So we're going to go over the slope formula. Hopefully we still remember some of this from algebra. But anyway, the slope formula. For 2 points, x1, y1, x2, y2, the slope is, and usually we use m for slope. So you guys remember like y equals mx plus b and all that? M was the slope. That's still the case. M equals, it's y2 minus y1 over x2 minus x1. So it's subtract the y values on top, subtract the x values on the bottom. You might have also heard of it as rise over run. That's another way to think of it, or change in y over change in x. Anything like that works. So there's our slope formula. Give everyone a moment to write that, and then we'll get going finding some slopes. Okay, so here's our first example. We're going to find the slope between the point -3.7 and the point 6.3. If you already feel confident about finding slope, you go right on ahead and find the slope. If you feel a little bit less confident, then maybe stick with me and I'll do it here for us. Okay, so first we want to label our points. Just like when we would do distance formula or midpoint formula, we're going x1, y1, x2, y2. So remember, the x values are x's, the y values are y's. Then all we have to do, y2 minus y1 on the top, so 3 minus 7 on the top. And then x2 minus x1 on the bottom, so 6 minus -3 on the bottom. Now remember, minus a negative is like adding a positive, so on the bottom it'll be like plus +3. 3 minus 7 gives us -4. 6 plus 3 gives us 9. So -4/9 would be our slope there. And if you get a fraction that reduces, you can reduce the fraction. If you get a fraction that does not reduce, like in this case, then you just leave it the way it is. So this would be our answer if we were asked what is the slope between these 2 points. All right. We'll do another slope really quick. You guys try this one. We'll find the slope between -3.5 and 0, -1. So take a moment, try finding the slope. When you are finished, type done in the chat. All right, if this is what you did for your equation or for your expression to start with, you're on the right track. All right, and then if you got -6 on top, -1 minus 5 is -6. And then 3 on the bottom, 0 minus -3 is like 0 plus 3. Then you're on the right track there. -6 divided by 3 is -2. That one does reduce to something nicer. So that's going to be the slope between those 2 points. Just a quick side note for slope. If you get something in the form of like 0 over something, then your slope would be 0, because 0 divided by anything is 0. If you get it the other way around, though, if you get something divided by 0, then your slope is undefined. So if you get something over 0, that's an undefined slope. So just something to be aware of that we can get when we find slopes. All right, so anything divided by 0 is undefined because you can't divide by 0. Anything that is 0 divided by something, that's just equal to 0. Okay. So now we're going to kind of shift gears. We've reviewed slope a little bit. Now we're going to talk about slopes of parallel lines and slopes of perpendicular lines and things like that. So if your lines are parallel, they are going to have the same slope. Parallel lines have the same slope. Okay. And if you think about, like in a coordinate plane, things that have the same slope, it's just the same line but moved around, right? So those lines would be parallel, they have the same slope. Okay, so for example, if we had the line y equals 3x plus 10 and y equals 3x minus 12, how do we identify the slope in those lines? Or what would the slope of those lines be? Does anyone know? Anyone remember? Well, these ones are in y equals mx plus b form, right? So if m is the slope, that number, whatever it is that's next to the x, is your slope. So if your lines have that same number for the slope there, then they would be parallel. So these two lines would be parallel because they have the same slope. Okay, so that's parallel lines. Give everyone a moment to finish writing. And then we're going to talk about perpendicular lines. I'm going to need another piece of paper. Slopes of perpendicular lines this time. Hey, Ashlyn, good to see you. Hey, Diego, good to have you here as well. All right, slope of perpendicular lines. Perpendicular lines. All right, so the rule here is that perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. Okay. Perpendicular lines have negative reciprocal slopes. And what perpendicular lines look like, remember, are lines that meet up at a 90-degree angle at their intersection. And that was our symbol for it, right? Perpendicular, meet at 90 degrees. That was the idea we had behind perpendicular lines. Okay, so now we have to ask ourselves, well, what is a negative reciprocal? What is a negative reciprocal? Drop my pen. All right, negative reciprocal. Well, to find a negative reciprocal, you have to do two things. So let's negative reciprocal. You have to flip the fraction. And you have to change the sign. Okay, so flip the fraction over and then changing the sign. So if it's positive, make it negative. If it's negative, make it positive. That's how you find a negative reciprocal. So positive becomes minus, or negative becomes positive. Either one. Okay, so for example, what is the negative reciprocal of 3/4? Well, we have to flip the fraction, right? So it becomes 4/3. And then we change the sign. So instead of positive 3/4, it becomes negative 4/3. So this would be the negative reciprocal of 3/4. That'd be the negative reciprocal of 3/4. What about the negative reciprocal of 5? Well, 5's not a fraction to start with, right? What can I do to make 5 a fraction? I can just put it over 1, right? 5 divided by 1 is 5. Owen's got the right idea going here. He already knows the negative reciprocal. Yeah, so 5 becomes 5/1. Flip the fraction, becomes 1/5. Change the sign, becomes negative 1/5. So that'll be the negative reciprocal of 5. All right, let's do one more. What would the negative reciprocal of -3/2 be? Your turn to try this one. Find the negative reciprocal of -3/2. Once you think you got it, type it in the chat. Flip the fraction, change the sign. All right, you're very close, Luis. Gavin, you got it. So we have to flip the fraction, right? So it becomes 2/3. And we have to change the sign because this one's already negative. If it's negative, you have to make it positive. Nice, Cheyenne. Yeah, so we have to go 2/3. And it's going to be positive 2/3 since it was already negative. So we change it to positive. Okay, so the idea is if it's negative, you make it positive. If it's positive, you make it negative. And then you flip the fraction over. That's what a negative reciprocal is. So if we're looking for things that have negative reciprocal slopes, for my perpendicular lines up here, I'm going to add something to my notes up here. For example, if we had y equals 5x plus 4 and y equals -1/5 x minus 9. This number here doesn't really matter. The slope is what matters. So if I were to take that 5 and that -1/5, if those numbers are negative reciprocals, that means our lines are perpendicular. Okay. So that's the idea there. Any questions up to this point? Any numbers we're not sure where they came from? Things we're not sure how they work yet? Okay. So let's go into some questions that we might see on homework and things like that. So this rest of this is going to be examples. We might be given two lines, like some points that are on two lines. We might be given point A is 2, 6. Point B is 5, 10. Point C is 12, 5. And point D is 9, 9. And we might be asked, are lines AB and CD parallel, perpendicular, or neither? Parallel, perpendicular, or neither? Okay. So if that's what we're asked, there's kind of some steps that we can take to solve this. Step 1 would be to find the slope of the first line, AB. So we do the slope formula between those 2 points. Step 2 would be to find the slope of CD. So do the slope formula between those 2 points. And then step 3 is to kind of compare the slopes. If they're the same, then they'll be parallel. If they're negative reciprocals, then they'd be perpendicular. And if neither one of those things are true, then we would pick neither. Okay, so let's start by finding the slope of AB. So step 1, find slope of AB. Okay, so using our slope formula, if you don't remember what the slope formula was, take a look at the beginning of your notes again, where we had that y2 minus y1 over x2 minus x1, that rise over run. So we have x1, y1, x2, y2. So we're going y2 minus y1 on the top. So 10 minus 6 on the top. X2 minus x1 on the bottom. So 5 minus 2 on the bottom. 10 minus 6 is 4. 5 minus 2 is 3. So our slope of AB is 4/3. Okay. Step 2, find the slope of CD. So if you feel comfortable doing that already, go ahead, find the slope of CD. You've got 9 minus 5 over 9 minus 12. You're on the right track. You should get 4 over negative 3. And then step 3, decide. If they are the same, then they would be parallel. If they are negative reciprocal, that would be perpendicular. If neither one is true, then neither. Okay, so what do we think? Are these two slopes exactly the same? Well, we have 4/3 and we have negative 4/3. So nope, not the same. Are they negative reciprocals? Well, the easy way to tell on that is to find the negative reciprocal of one of them and see if it's equal to the other one. So the negative reciprocal of 4/3, we flip the fraction and we change the sign. So 4/3 would become negative 3/4. Is negative 3/4 the same as 4 over negative 3? No. So that means they're not negative reciprocals. So then that must mean that neither is the case. So our answer here would be that these two lines are neither parallel nor perpendicular. Neither one of those things is true. Okay. So that's one type of question that we could see. We go over 2 more types. They're going to be a little bit less heavy on finding the slope using the slope formula. 2 more kinds of questions and then we're done. Next example. Let's say that one of our lines is y equals 4x minus 7, and the other line is y equals negative 1/4 x plus 13. And we're going to be asked, are these parallel, perpendicular, or neither? Okay, so first we have to identify our slopes. So our slopes here are 4 and negative 1/4. 4 and negative 1/4. All right, so are those the same? No, 4 and negative 1/4 are not the same. Because those are two different numbers, right? If they are the exact same number, that's how we know that they're parallel. If they are different numbers, then no, they're not the same, they're not parallel. Are they negative reciprocals? Christy thinks so. Anyone else think so? Yeah, we can check real quick, but you guys are right. The negative reciprocal of negative 1/4 is to flip the fraction and change the sign. So instead of 1/4, it would become 4/1. Instead of negative, it would become positive. Positive 4/1 is equal to 4, which is the same as the slope of the other line. So yes, those are negative reciprocals. Since we figured out that they are negative reciprocals, we can say that they are perpendicular. Perpendicular. Okay. That's another kind that we might see. The last kind that we might see line L has a slope of 3/2. What is the slope of a line parallel to line L? Well, if it has a slope of 3/2 and parallel lines have same slopes, what's the slope of our new line? Yeah, also 3/2. So this one is easier than it seems. The other slope of our new line would be 3/2. What if we wanted our line to be perpendicular to line L? So if it's parallel, we leave it. If it's perpendicular, yeah, we flip the fraction and change the sign. We make the negative reciprocal. So Owen's got it. It's -2/3. And we can say m equals 3/2 and m equals -2/3 if we want to, just so that we are using our notation for slope and everything like that. So those are the kind of questions that we're going to be asked today. Any numbers that don't quite make sense or anything we're not sure where it came from at this point? Any particular steps or anything like that? Or a particular example that we want to go back to? Okay, then I'm going to go ahead and post the assignment. Today's assignment is going to be from IXL. I'm going to post it and then we're going to talk about it real quick and maybe go over a couple of examples. Okay. So it should now be posted in the Google Classroom. I will also post the notes later. Okay, so there are two IXL sections. One is just finding slopes of lines. So it'll give you things like 2 points, and you will find the slope between the 2 points. It'll also give you stuff like this, where it'll ask you, what is the slope of this line? So you would just pick, okay, -2 is right next to the x there, so -2 is my slope. There will be questions like those. see. There'll be questions like these where you use the slope formula, that sort of thing. So that's one of our sections. The other section is about parallel and perpendicular or neither, things like that. So it'll say things like line G has a slope of -9/2. Line H is parallel to line G. What is the slope of line H? So the key word you would think, okay, parallel. If they're parallel, we know they have the same slope. So if the one slope was -9/2, we'd also say -9/2. And then it'll say something else like line F has a slope of -5/2. Line G has a slope of 3/2. Are they parallel, perpendicular, or neither is also an option? So we go, okay, well, they're not the same because -5/2 is different than -3/2. So they're not parallel. And then if I find the negative reciprocal of one of them, yeah, Christy's got it. It is neither because the negative reciprocal of -5/2 is 2/5, which is not equal to 3/2. So neither. All right, so then the kind of questions that were just like those examples that we were doing. So you've got those two sections for today to a SMART score of 80. And then I will also post an exit ticket. And you guys are now free to go and start working on those. If you have questions, stick around or pop back in. I'll be here for the rest of the period, which is done at 11. Otherwise, have a wonderful Monday.